So starting with, we did halogens, we did, now we're going to do nitrogen and sulfur. Uh, so the first thing is, most of the things are very obvious. The first thing is that, I mean, you already know that nitrogen makes up 78% of the atmosphere and it's a very inert gas. Why is it a very inert gas? Because it has a triple bond and it's very hard to break that triple bond. That's the first thing. Sometimes, and it's very strong. Plus, you can add that it's non-polar as well, because in one of the past papers, you got a question where they were asking, where they had stated that there are two molecules. One is carbon monoxide, that it also has a triple bond, and you have nitrogen, which also has a triple bond. But they're saying that carbon monoxide is reactive, whereas this N2 molecule is very unreactive. It's inert. So, and they were asking for the reason. Now you can't really state that it has a triple bond. And it's very hard to break the triple bond because carbon monoxide also has a triple bond. So the only explanation for that was that carbon monoxide is a highly polar molecule with the oxygen being partial negative and the carbon being partial positive, and therefore it's going to be reactive because polar things would attract. I mean, this molecule would attract other molecules. So it's going to attract other molecules. So so one important thing is that N triple bond N is very strong. It's a triple bond. But the other important thing also is that it's a non-polar molecule. It doesn't really attract other molecules. It's not attracted to electrophiles. It's not attracted to nucleophiles because it's mostly non-polar. Okay? Is this clear? Isaac, is this clear? Ibrar, Bhaskar, is this clear?
Yes.
Yes, sir.
Yes, sir.
And the other thing is that sulfur is present in, I mean, this is about sulfur, that it's present in ZnS. This is known as zinc blend. I mean, this thing over here, it's an ore of sulfur and zinc, and it's known as zinc. It's known as zinc blend. So, plus it's also sulfur is heavily present in fossil fuels, especially the raw fossil fuels like coal. And volcanic activity also produces volcanic ash, etc. Volcanoes, they emit a lot of sulfur in the form of sulfur dioxide. So this is where you're getting the two gases. Then we're going to talk about acid rain a bit. How is acid rain formed? Which you already know that in extreme temperature, especially in car engines and lightning strikes, the air burns up. The nitrogen in the air and the oxygen in the air, ठीक है, both of them are already present in the air. ठीक है, so at very high temperature, air burns. The nitrogen and oxygen, which usually don't react, they start reacting with each other to produce NO and NO2. And the NO2 is an oxidizing agent, and SO2 is a good reducing agent. They both start to react with each other. And NO2 is behaving as a catalyst basically here. I mean, it is acting as an oxidizing agent, but it's basically behaving as a catalyst because it remains unchanged at the end of the reaction. So NO2 is an oxidizing agent and SO2 is a reducing agent. They both start to react with each other. The SO2 gets oxidized to SO3, and the NO that got reduced, NO2 got reduced, but it gets oxidized in air again to form NO2. Now, the reactions for acid rain are actually missing over here. We need to add them. Okay, how is acid rain formed? That when rain happens, the SO3 that has been formed would react with the water, and this was hydrolysis of SO3. It would react with water to form H2SO4. And the same happens to NO2, that it reacts with water but it forms two different acids. One is HNO3 and the other one is, I said the other one is HNO2. So two different acids are formed, nitric and nitrous acid. So you get all these acids that are getting formed through acid rain. And then you have that acid, you pretty much know what acid rain does, that it causes corrosion of limestone buildings, metal structures, soil and water bodies that become acidic, and you get skin and eye irritation. So that's the effect on human health. Then the other things are that, now the other thing that we're going to talk about is, not fluke, just one second, let me quickly see if that's, okay, related to acid rain, there's something over here which should be discussed first. Now your soils are becoming acidic. So how would you neutralize those acidic soils? Okay, the soils are becoming acidic. How would you neutralize them? You're going to add two things. One is lime, and the other thing that's available is limestone. So calcium hydroxide and calcium carbonates are added. Calcium carbonate is basically chalk, and calcium hydroxide is also formed from calcium carbonate by decomposing it. You decompose calcium carbonate, you get calcium oxide and water, not water, carbon dioxide. So both of them, one of them is a base, the other one is a carbonate. They can neutralize the acid in the soil, which and the soil was becoming acidic because of acid rain. So that's one thing. Then there's a thing called flue gas desulfurization, and that is that a lot of your industrial gases that are emitted, fumes that are emitted, they have SO2 and NO2 in them because you're burning fossil fuels, right? And because of combustion, the air heats up, the air burns as well, and you get NO2 as well. So most of the gases in the chimneys that are coming out, they both contain sulfur oxides and nitrogen oxides, and they need to be removed. And they can also be removed by adding limestone or lime because both of them are basic, and they can form salts. The sulfur dioxide and nitrogen oxides, they can turn into salts, calcium sulfide and calcium nitrate, and also calcium nitrite is possible in this one. Okay, that's also possible because NO2 produces two acids. One is HNO3 and the other one is HNO2. So nitrate and nitrites both can be produced by NO2. So that's flue gas desulfurization. Then you have to remember a few things about the Haber process. How is ammonia formed? Uh, Nitrogen and hydrogen, they react together and you get ammonia. Uh, Iron is the catalyst. You need to know the temperature. 450 and 200 atmosphere is the pressure that's used. The pressure is usually between 100 and 500. Uh, so there's a range of temperature usually given. The source of nitrogen is fractional distillation of liquid air. Hydrogen is coming from cracking of oil, but there are other sources of hydrogen as well, like electrolysis of water, which basically means electrolysis of any aqueous solution. Like if you electrolyze NaCl aqueous, you get hydrogen gas there as well. I said then there's some questions asked about equilibrium related to this. Now remember, equilibrium. This is an exothermic reaction. See, the reaction over here is an exothermic reaction. When are exothermic reactions favored? At lower temperature, so because it's an exothermic reaction. Why are high pressure used? High pressures would favor less gas moles. If you know Lee-Shatler principle, that if you increase the pressure of a gas or an equilibrium container that contains equilibrium, less gas mole side is going to be favored. Which in this case is the forward side, because in the backward side you have 4 moles of gas being formed, In the forward, there are only two molecules of NH3 getting formed. So less gas moles side is going to be favored. And the other thing is that if you constantly remove NH3, equilibrium would try to make more NH3. That's the de Châtel principle. It's going to do the opposite. So the equilibrium tries to make, it's going to try and make more NH3. So this is de Châtel principle. Is this clear, Ethan? Do you get this, Mohammed?
Yep.
Okay, so
Yes, sir.
so just remember, lower temperatures are going to favor exothermic reactions. It's an exothermic reaction. High pressures are going to favor the less gas mole side, uh, because if you compress things, the volume decreases, so you can't get more gas. You're going to get less gas. And if you keep on removing NH3, it's going to try and make more NH3. Um, but the conditions are not used. There's some practical problems with this. That high pressure increases the economic cost, and it's dangerous as well because you have to make really thick pipes, and there might be explosions because of high pressure. And you can't really use a very low temperature because if you use just one second. So if you use a low temperature, the speed of reaction would be lesser. So both of these conditions, I mean the conditions that we discussed over here, they have some practical problems. So which is why this is like an in between, a trade-off. You can't use a very low temperature. The reaction would be very slow. You're going to get more NH3, but after a very long time because the reaction is slow. And high pressure is using a very high pressure like 1000 atmosphere. That's going to be dangerous and too costly to be implemented practically. So these conditions are a trade-off. So they might ask you about, and they might actually ask the same thing about some other reaction. Uh, there's equilibrium favoring something is something different, and practical applications or practical details are something else. So that's the Haber process. One thing you must know about the Haber process is that the yield is very, very low. I mean the yield is terrible actually. It's around 10%. Like if you add N2 and H2 into the mixture, let's say this is the place where the whole reaction is happening. And what you do is from in the output you remove the NH3. So the NH3 is removed. Whereas the N2 and the H2 are again fed into the system. The yield is around probably less than 10%. So everything has to be recycled over and over again. You keep on removing NH3 by cooling, because it has NH3 because it has hydrogen bonding. It has a relatively high boiling point and melting point compared to N2 and H2. So it could be removed by just cooling it, and you can liquefy it, and you can simply remove the liquid, and the gases can be fed back into the system. Okay, so approximately 10% is the yield. So most of the gases, the equilibrium is really favoring the reactants, not the products. So you're not getting a lot of NH3 in the first place. Then some uses of NH3, fertilizers is one of them. Most fertilizers are NPK salts, which contain nitrogen, phosphorus, and potassium, and uh, salts containing ammonium are going to be having N in them. So you have a lot of fertilizers containing N in it. So that's one purpose of NH3. Then you make nitric acid out of NH3, and you also make explosives and detergents and dyes, etc. And then there's the contact process, which you've also studied in O levels, which is that sulfur and oxygen they react to produce SO2, and then SO2 and O2 they react to produce SO3, which is an equilibrium reaction. And always remember, whenever you burn sulfur, I mean, this is basically sulfur getting burned. So this is burning of sulfur. Now remember that when you burn sulfur, you never actually get sulfur dioxide. So you always get sulfur dioxide, you never get sulfur trioxide because of combustion of sulfur. Uh, so so whenever somebody's if for example in your paper they are asking you to make an equation of sulfur burning, make SO2 not SO3. Okay? SO3 is formed with a lot of difficulty that you would have to do a lot of things to make SO3. Vanadium pentoxide is used as a catalyst, 1 to 3 atmospheres and 450 degrees centigrade is the temperature. This reaction has a very good yield. So you don't actually need very extreme conditions. Although the equilibrium is going to favor the forward reaction at low temperature because it's also an exothermic reaction, and high pressures because it's going to favor less gas moles, which is going to make it go forward. But the thing is, you don't really need a very high pressure because the yield is already very good. It's around 97%. So the reaction pretty much goes to completion. And the same practical details that you can't really use a very low temperature because the reaction would slow down too much, and you can't really use a very high pressure because the cost would increase, and you don't need the high pressure in the first place. And again, where do you use sulfuric acid? The last step is that SO3 is added to concentrate sulfuric acid. The reason you're not adding it to directly to water is that it would form H2SO4, but the reaction is going to be too explosive. So not suitable in an industrial setting. So which is why SO3 is instead dissolved in concentrate sulfuric acid, not in H2SO4 to get oleum, and oleum is then diluted with water to form two molecules of H2SO4. So basically what you're doing is you're using H2SO4 to make more H2SO4. Uh, Directly adding to water that's kind of explosive, not practically suitable. So then there is the nitrate thing I mean nitrates. How do nitrates end up in soil? That you have in the air, you have a lot of nitrogen oxides being formed, and they turn into acid rain. And then you're adding fertilizers as well. So lots of nitrates uh, are being absorbed by plants, and plants need nitrates in the first place. Now, then there was a thing in O levels that you studied about the harmful effects of excess fertilizer. And that's eutrophication. That fertilizers, they get washed away because they're very soluble. They have to be very soluble because plants can only absorb substances through water. So they have to be dissolved in water. So they have to be soluble things, soluble NPK salts. Now they get washed away into rivers and lakes, and they promote algae growth and blocks sunlight, and which basically destroys marine plants because there is no sunlight. And bacteria then feeds on the dead plants, consumes all the oxygen, which and because of which marine life and fishes they start to die. This is already done. One other thing is that lime and fertilizers, lime was being added to neutralize acidic soils. Fertilizers were being added to add nitrates and phosphates and NPK salts into the soil. These should not be added together. Why? Because ammonium salts, they tend to react with bases to form salt, water, and ammonia. I mean that's an acid-base reaction that happens. That whenever an ammonium salt is whenever an ammonium salt is added, I mean this happens. One second. Remember, ammonium or any salt that contains ammonium, that's acidic because it's capable of losing H plus ions. Anything that's containing OH ions, that's basic because it's capable of gaining H plus one ions. What happens is NH4 plus 1 gives off NH plus 1 to form NH3, and OH minus 1 they end up gaining an H plus 1 to form H2O. So that's what the ionic reaction is. So any fertilizer that contains an ammonium salt uh, and lime, they should not be added together because ammonia gas is going to be produced and the gas would be released, which would reduce the amount of nitrogen in the soil. You wanted more NPK in the soil, but if NHC gas starts forming, there would be less N in the soil. Okay, is this clear, Bazga, Ibrar? Abba, is this clear?
Yes, sir.
Yes, sir.
Okay, then something about catalytic converter that catalytic converter targets three things. One is that there's carbon monoxide which is being produced due to incomplete combustion. It's a very harmful gas because it combines irreversibly with hemoglobin, with the iron that's in the hemoglobin, and which is why the hemoglobin basically gets destroyed or gets redundant. It's no longer able to carry oxygen. So that causes choking. And then you have nitrogen oxides because the air is burning up in the car engine, and there's unburnt fuel. And what happens is the equation is messing. Let me write the equation. What's going to happen is that the catalytic converter is a honeycomb structure made of palladium or platinum. So all the exhaust gases they travel through it. So you have carbon monoxide and you have unburned hydrocarbons and you have oxides of nitrogen. Now, remember we discussed this. This is an oxidizing agent. So it kind of plays its role over here as well. If you add a catalyst, it starts playing its role. It starts oxidizing carbon monoxide to carbon dioxide. The unburned hydrocarbons are also oxidized into carbon dioxide and H2O, and itself it gets reduced to nitrogen. It completely gets or loses all its oxygen and gets reduced to nitrogen in the presence of a palladium or platinum catalyst. So this is the reaction that happens. You can balance this equation. The last couple of points are that NHC is basic, and remember NO is colorless, NO2 is brown. Um, I'm going to discuss this point as well, which is that NO2 is an oxidizing agent. Just we've already discussed that its role as an oxidizing agent. It was acting as an oxidizing agent in the formation of acid rain because it was oxidizing SO2 to SO3, plus also in the catalytic converter. Now, it also plays its role in the formation of ozone. What it does is that NO2 reacts with the normal oxygen and ends up producing. Itself gets reduced to NO, and O2 gets converted into ozone, O3. Achha, so this is one reaction. I'm just going to briefly discuss about this reaction and also about ozone. Now, ozone is this hazy substance. It's like a fog-like substance that's present in the upper atmosphere. So it's this fog-like substance. Uh, and it reflects the UV light, harmful sun rays. So if you have a lot of ozone, then sun rays would not be able to reach the surface of the Earth. We just have the right amount of ozone that the UV rays they get reflected back, and the harmful rays get reflected. The rest of the sunlight is able to pass through. Now the problem with this reaction is that this reaction is also happening in the lower atmosphere, especially in cities. Now, why is it happening in the lower atmosphere? Because you have a lot of car engines in a city, especially in the city. So car engines are producing, they're burning up air all the time. There's nitrogen and oxygen they're reacting in the car engine. So now that what's happening is that in the lower atmosphere you get a lot of ozone, a lot of O3. That's basically your the smog. Anyone who's living in a big city would notice this haziness. ठीक है? The air would not be clear. Uh, Even on a good day, the air is usually not. You can't really see very far. So that haziness is basically ozone because your car engines are constantly burning up air. They're constantly producing NO2. There's a lot of NO2 in cities, and the oxygen around you is getting oxidized to O3. So you're getting ozone in the city, and that basically forms a major chunk of the smog that you see in a lot of cities. I mean, it's not the normal fog. Normal fog is water vapors. Smog is a lot. It's very harmful, and it causes a lot of breathing issues because just like carbon monoxide, ozone also combines with your hemoglobin, and so in some cities it's like living in some cities is like smoking 22 cigarettes a day because there's a lot of O3 in the city in the lower atmosphere. So, so that's about it. That's all about nitrogen and sulfur. Most of the things you've already done previously as well. So we're going to do some past paper questions now. Okay, is this all clear? Rida, is this clear? Abha, is this clear? Basa, clear?
Yes.
Yes, sir.
So let's, one second. So we're going to do questions on nitrogen and sulfur now. Let's do this one. So let's start. Most of the questions are just repetitive questions. Uh, so state three essential operating conditions of the Haber process, which I'm sure we're just going to do them. One second. So Haber process is 450 degrees centigrade. What was the pressure? 200 atmosphere was the pressure, and you have iron as the catalyst. One large scale use of ammonia is fertilizer. Write a balanced equation for the Haber process. You can pretty much do that. Then you have ammonium may be prepared in a school laboratory by using the apparatus shown. So the reaction involves the displacement of ammonium from one of its compounds. Give the formula of the two reactions that are heated together to produce ammonia. So you can pretty much do that. That's given over here. It's ammonium chloride and calcium hydroxide, and construct a balanced equation for the reaction. So remember, ammonium salts NH4Cl plus calcium hydroxide, that's Ca and OH twice. NH3 and H2O are going to be produced. Okay, remember, it's an acid-base reaction because in Bronsted-Lowry acid-base theory, uh, NH4 is going to produce H plus ions and OH is going to accept H plus ions. And the salt is going to be the leftover ions, which are going to be calcium chloride. And you can balance this equation. Then you have common drying agents include calcium oxide, sulfuric acid, and phosphorus oxide. Which one of these would be used in the drying tower in the experiment? Explain your answers. You have this drying tower over here, and ammonia is being produced. Now remember, ammonia is basic. Okay, that's given in the notes as well that NH3 has a lone pair. And these lone pairs, they accept H plus ions. So it is basic. So you don't want drying. The purpose of a drying agent is to remove water molecules, not to actually change the ammonia or react with the ammonia. So you don't want acidic things. Okay, the drying agent should not be acidic because otherwise the ammonia would react. You want to dry it, not react it. So, which is why sulfuric acid would be out of the question. And phosphorus oxide is, if you remember period 3, that's also acidic. Phosphorus 5 oxide is P4O10. It reacts with water to form HCpO4. So this is an acidic oxide. It should not be used. Uh, so the only thing left is calcium oxide. That would be a good drying agent because it's also basic. So basic things don't react with other bases. Then you have ammonia as a weak base which forms salts containing described with an aid of an equatorial formation and structure of the ammonium ion. You should use displayed formula in your answer. So what happens when an ammonium ion is formed? A dative bond is formed. Like N has lone pairs and H plus 1 has an empty orbital or a completely empty shell. It has no electrons whatsoever. So it's going to be datively attracted to NH3. And you're going to label this. This is going to be a dative bond. That's pretty much it. So the rest of the questions are all about the same thing about contact process as a this one. Now you have to outline with the aid of equation how acid rain is formed from the exhaust gases of motor vehicles. So you're going to talk about NO2. First thing is N2 and O2, they react together and they end up producing oxides of nitrogen. So let's say they produce NO2 and then NO2 reacts with the SO2 in the atmosphere. Remember, car engines don't really produce SO2 because cars use a very refined fuel, which doesn't have a lot of sulfur in it. Most of the unrefined fuel has a lot of sulfur in it, especially coal. So this would form SO3 and NO is going to be produced, and then you're going to oxidize NO back into NO2. And then you can write the equation for acid rain, which is that SO3 would react with water to form H2SO4, and similarly you can write the equation for NO2 as well. Environmental effect, as I remember, focus on this word because people make a lot of mistakes. There are three effects. Effects on building, that's not an environmental effect. Like if you write that limestone buildings corrode, that's not an environmental effect. Soil and water bodies become acidic, that's an environmental effect. Uh, so always differentiate on what type of effect is he really asking for. So then one thing I think that was missing was SO2 acts as a food preservative. I think that's probably missing in the notes. Maybe let me just quickly check. I mean, I think we should separately add this. I mean, this is an important point. Remember, SO2 is a good reducing agent. You probably studied this in O levels as well. So it's a very good reducing agent. And the reason it's going to be used as a food preservative is because of this very property. It's used in two things. One is that it's used in bleaching wood pulp, and the other one is food preservative. So why food preservative? Because if you have a canned food or something packed in a closed container, uh, so let's say there's this box and it has food in it, you want SO2 to be over here. The reason you want SO2 to be here is that SO2, if there is any amount of oxygen present, SO2 is going to react with that oxygen to produce SO3 because it's a good reducing agent. So the SO2 would eventually react with the oxygen to produce SO3. And it's going to remove the oxygen. Oxygen is needed for bacteria to grow or multiply. So if there is no oxygen, because the SO2 is consuming all the oxygen, there would be no oxygen, and the bacteria would not be able to multiply in a container. Okay, is this clear? Mohammed, is this clear? Aiza? Abba, is this clear?
Yes.
Yes.
And you can also add that SO2 is also used to bleach. It bleaches wood pulp. I said, that's where's the worksheet? I said, then you have, again, this is mostly about Haber and Carteret process. This is about uncontrolled use of nitrogen fertilizers can cause environmental damage to lakes and streams. This is known as eutrophication. So they're asking about what are the processes that occur. So you're going to talk about algae growth, sunlight being blocked, and plants dying, and bacteria feeding off those dead plants and multiplying and consumes all the oxygen, so that it's no longer able to support marine life. Uh, so carbon monoxide is incomplete combustion, and nitrogen monoxide in the internal combustion engine is going to be produced when nitrogen in the air would react with oxygen in the air. And the main hazards is this is going to cause choking, breathing problems, and this is going to cause acid rain. Metal used in the in the catalytic converter, that's platinum or palladium. Platinum is way too expensive to be actually used, and they're asking you to how would the catalytic converter convert these gases into less harmful gases, and he's asking you to make an equation. So carbon monoxide and nitrogen monoxide are going to get converted into carbon dioxide and N2. Explain the lack of reactivity of nitrogen. So you're going to write two things. One is that the triple bond is very strong, plus it's non-polar as well. Uh, so one reaction would be the nitrogen and oxygen reaction, and the conditions would be very high temperatures. Or you can write the Haber process. That's another reaction of nitrogen. Um, so pretty much all of the questions are just I'm just trying to look for some questions which are different. So again about the poisonous gases. So there's gas one and gas two. That's carbon monoxide and carbon and nitrogen oxide. Okay, so let's try and do something else now. Okay, most of the questions we're going to do past paper questions. So most of it is just memorizing this stuff. So what I want to do now is there's another small topic which is called one second. I said there's another small topic which is called Bronsted-Lowry acid-base theory. So let's try and do that. Okay, that's a very small topic, and that's it's simply that I said now this topic is that by definition acid is a proton donor. A proton is an H plus 1 ion because the H plus 1 ion only contains a proton. And the base by definition is is a proton acceptor. So that's it. Now, there are multiple definitions for Bronsted-Lowry acid-base theory. I said there are multiple definitions of acids and bases. This is the definition that you're going to stick with. There's an Arrhenius definition which says that an acid is an H+1 donor and a base is an OH ion donor. So that's called an Arrhenius definition. Then there's another definition which says that an acid is an uh, H+1 acceptor. Sorry, not an H+1 acceptor, a lone pair acceptor, and a base is a lone pair donor. So the definition that you're going to stick with is this one. It has to. You're never going to mention OH ions when you're defining Bronsted-Lowry acid-base theory. Now, this would make the definition very broad. Uh, each one has a different classification. This one is kind of a very broad definition. The reason why it's a broad definition is that any molecule anywhere, if it's doing something with H+1 ion, that's going to be classified as an acid or base. For example, if you have this reaction happening, and eventually you get these as the products. And you get this as a product. Which one do you think is behaving as an acid according to the definition? What is H2SO? Yes.
Sulfuric.
What is H2SO4 behaving as?
Base.
What is it doing? Is it losing H+1 or gaining
It
H?
is gaining. It is. It is losing a proton.
So it's losing an H+1.
Mm.
Since it's losing an H+1, it's behaving as an acid. So you're going to classify this as the acid. And what is, the HNO3 is obviously gaining H+1. So it's behaving as a base. So remember, the definition is a lot broader now. Any molecule, no matter in what condition, if it loses H+1, that's an acid. If it gains H+1, that's a base. So this one over here is a base. And then whenever you have an acid-base reaction, acid-base reactions are usually reversible, which means the reverse could also happen. That if something could gain H+1, it could also simultaneously, uh, at the same time, or maybe later, lose an H+1. So the reverse is also possible. So if you look at HSO4 minus 1, what is it doing in reverse? What is it behaving as?
Base.
So in reverse, it's gaining an H+1, it's behaving as a base. And when you talk about the reverse, you call it a conjugate base. This is going to be your conjugate base. And H2NO3 would be your conjugate acid, because if you look at H2NO3, then in reverse, it's losing H+1 ions. So it's going to be your conjugate acid. So you start using the word conjugate with so the reverse is conjugate, the forward is just acid base, uh, and pretty much these reactions. The products and the reactions are arbitrary in a reversible reaction. This equation could have been written in the other way around as well. Like these could be on the left side, these could be on the right side. It would still remain the same equation. So most acid-base reactions, all of them, if they can gain H+1, they can also lose H+1. If NH3, if NH3, gains H plus 1 to form NH4 plus 1, then it could also lose H plus 1 to form NH3 back again. So remember, acid-base reactions are reversible. But the thing is, let's look at HCl. पहले तो बताओ कि is HCl a strong acid or a weak acid?
Strong.
ठीक है, it's a strong acid. Now, what you have been taught is that HCl ionizes and produces two ions. One is H plus 1 and the other one is Cl minus 1. But the thing is, okay, there is no H plus 1 actually in reality, in aqueous state. I mean, you've been taught that HCl dissociates, ionizes, and produces H plus 1 aqueous, right? So, but the real situation is there is no H plus 1 aqueous. Because what happens is H plus 1 aqueous means that the water molecules and the H plus 1 ions are mixed with the water molecules. But remember, water molecules are highly polar and they have extremely negative lone pairs. And eventually what happens is that the H plus 1 gets attracted by the lone pairs and it ends up forming a dative bond with the water molecules. And that's your H3O plus 1 ion. That's called a hydronium ion. Okay, is this clear, Mohammed? Ethan, is this clear? Basa, is this clear? Abba?
Yes.
Okay, so always remember that whenever you hear about acids dissociating in aqueous state to form H plus 1 ions, they're not actually forming H plus 1 ions because there's no H plus 1 ions roaming around in water because all the H plus 1 ions are going to eventually form a dative bond. So
Sir, if
yes,
water is a polar molecule and H plus 1 ion gets attracted to oxygen, why shouldn't chlorine get attracted to hydrogen then?
why doesn't chlorine get attracted to hydrogen?
Hydrogen.
That's a valid question. It does get attracted to hydrogen, and it might get attracted to hydrogen to form HCl gas back again. Okay, this might happen. But the thing is, it depends on the strength of the negative charge. But okay, let me explain this further. See, if you just one second. एक second after. Just so imagine all these water molecules, right? So let's say these are water molecules. ठीक है, lots of them. बल्कि हाथ से draw कर लेते हैं. 1 second. So there's HCl gas, you're mixing it with water, and the HCl breaks down into H plus 1 and Cl ions. One second. ठीक है ऐसा. अच्छा, so H plus 1 and Cl ions are breaking off. Now the reason they're not going to join up is that there would be lots and lots of water molecules in the middle. Okay, so there would be lots and lots of water molecules in the middle. Now, Bhaskar, tell me, uh, which one has a bigger chance? Will this H plus 1 get attracted to the Cl minus 1 or will it get attracted to the water molecule?
Water molecules.
Okay, and that's one of the reasons why HCl is a very strong acid because it dissociates, and one of the other reasons is that the Cl minus 1 has a very low negative charge density. It doesn't really attract the H plus 1 that strongly. So that's why there's
About ions of the water molecules.
which one?
Like if water is a highly polar molecule, oxygen would be negative, right? And water would have a permanent dipole positive charge. So why wouldn't Cl get attracted to that?
Okay, but the thing is, in that case, the positive is actually not that strong. Okay, the lone pairs. The lone pairs have a very strong negative charge density, and therefore they attract the H plus 1. The positive H is not that polar. Okay, I told you that in hydrogen bonding, the reason oxygen had a very strong negative charge was because it had these lone pairs. That's why the negative charge was way greater than the positive charge. Okay, is this clear? So I'll just quickly sum this up. That you have an HCl molecule and it would react with water. HCl would dissociate and produce H plus ions, but the H plus ions would be grabbed up by water molecules to form hydronium ions. And the Cl minus 1 ions are also going to be produced. Now the thing with this is this one is acting as an acid. Remember, the water is amphoteric. I mean, water can behave as both. At this point, water is behaving as a base. This is your conjugate base, and this is your conjugate acid. Because if you look at these molecules in reverse, you would notice that the Cl minus 1 is turning back into HCl. That means it's gaining H plus 1 ions. Okay, just a second. The board is hung up. I'm just going to add here. 1 second. So the Cl minus 1 is gaining H plus 1, so it's acting as a base. What about H3O plus 1? H3O plus 1 is losing H plus 1, so it's acting as your conjugate acid. Okay? Is this clear to everyone?
Yes, sir.
I said now the
Yes.
only
Yes, sir.
okay, the only point I was trying to make was that when you have a strong acid, then remember the reason it's a strong acid is because a strong acid is going to have a conjugate base, and the base is going to be weak, which means that HCl wants to lose H plus 1 to form Cl minus 1, not the other way around. Okay, do you get the point? That whenever you have a strong acid, and HCl is a strong acid, okay, we already know that it's a strong acid. A strong acid is always going to have a very weak conjugate base. And that's pretty obvious because HCl dissociates more. I mean, the equilibrium is shifted to the right. Most of the equilibrium is to the right. HCl ionizes almost completely. So the equilibrium is favoring the products, which means the forward reaction is happening, which means it's a strong acid. The reverse is not happening, which means it's a terrible base. It doesn't like to gain H plus 1 back again to form HCl. Is this point clear as well?
Yes,
Did
sir.
I? Hiba, Abba, is this clear? Minail, is this clear? So, so always remember
Yeah.
that a strong acid is going to have. Sorry, I lost the board. Just wait 1 second. Was I going to finish this here? Okay, a strong acid has. Okay, just 1 second. Ethan, is this clear? The last point.
Yeah, it's clear.
Okay, so a strong acid has. Where's the? As a strong acid has a weak conjugate base, and vice versa. You can pretty much make. If you have a weak acid, like for example, HCl was a weak acid. That means the forward was not happening, but the reverse was actually happening. So that means a weak acid would have a strong conjugate base. And the same for bases. Like if you have a strong base, it's going to have a weak conjugate base. If you have if you have a strong base, it's going to have a weak conjugate acid, like NH3. NH3 is a weak base, which means it doesn't really like to form ammonium ions. It doesn't really like to form or gain gain H plus 1 to form ammonium ions. Uh, but ammonium ions would be relatively a strong acid, strong conjugate acid. The forward is not happening, the backward is happening more. only then would the equilibrium be shifted to the left. Okay, so remember, it's the opposite. Strong acids, weak, they have weak conjugate bases. Weak bases are going to have strong conjugate acids. Is this point clear to everyone?
Yes.
Yes.
Okay, chale, let's do some questions tomorrow then on this. Okay, on acid, Bronsted-Lowry acid-base theory. Okay then.
Office.
Take care, Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz, sir.